Okay. The square of the radial wave function for an orbital. The square of the radial wave function. The square of the radial wave function. Radial wave function. The square of the radial wave function for an orbital gives the radial probability density R square. Radial probability density. Okay. R square gives the probability density of finding the electron at a point. So, R square gives the probability density of R square gives the R square gives the probability density of finding an electron or orbital, finding the electron at a point along a particular radius line. Finding the electron at a point along the particular radius line. Okay, I repeat, R square gives the probability density of finding the electron at a point along the particular radius line. Okay, to get such a variation, the simplest procedure is to plot R square against R. Okay, here to get this variation, graphs should be drawn between R versus R square. R square versus R. Okay, these plots give useful information about probability density at a point as a function of radius. These plots give useful information about probability density at a point as a function of radius. I repeat, these plots give useful information about probability density at a point as a function of radius. Okay, I repeat, these plots give information about probability density at a point as a function of radius. Okay, now first, for 1s, n is equal to 1, L is equal to 0. So graph is like this. This is R square, this is R. So for 1s orbital, curve starts at the nucleus. Number of nodes 0. Number of nodes is equal to 0 for 1s orbital. So graph is like this. For 2s orbital, this is psi square, this is r square. So number of nodes, 2s orbital number of nodes is equal to 1. So graph is like this. So for every s orbital, curve starts at the nucleus. For 3s orbital, curve starts here. So number of nodes 2. This is this graph for 3s orbital. Okay, for 2p orbital, for 2p orbital, n is equal to 2, l is equal to 1. So this is psi square and this is r. Number of nodes is equal to 0. So graph is like this. Okay. For 3p orbital, this is r square, this is r. Okay. For 3p orbital, for every p orbital, d and f orbital, graph starts at the nucleus. Since these orbitals do not find at the nucleus. Okay. So number of nodes 3p orbital, number of nodes 1. Number of nodes is equal to 1. Therefore graph starts here for 3p orbital. These are the radial probability density curves. So number of nodes is equal to n minus l minus 1. Okay, number of nodes is equal to n minus l minus 1. What is node? The region where the probability of finding an electron is 0 is called a node. Okay, next. Shape of orbitals. Okay, s orbital, for s orbitals, n is equal to 1, 2, 3, so on. L is equal to 0. It has a spherical shape. Okay. Electron density is uniformly distributed. In s orbital. Electron density is uniformly distributed in a s orbital. So s orbital has no nodal plane. S orbital has no nodal plane. Node is different from nodal plane. What is nodal plane? The plane in which the probability of finding an electron is 0. an electron is equal to 0. You can't draw a plane where probability of finding an electron is 0. Okay, because electron density is distributed in all the directions. Here in s orbital, electron density is distributed in all the directions. You can't draw a plane where probability of finding an electron is 0. So s orbitals has no nodal planes. For p orbitals, L is equal to 1. Orbital is equal to 1. P orbitals have dumbbell shape. For example, px orbital. Here, this is x-axis. This is a y-axis. This is a z-axis. Okay, p orbital has a dumbbell shape. So electron density is concentrated along the x-axis. So nodal plane is YZ. For px orbital, nodal plane is YZ. In YZ plane, electron density is 0. So nodal plane for px orbital is equal to YZ. Similarly, nodal plane for py orbital is equal to XZ. Nodal plane for pz orbital is equal to XY. So p orbital has only one nodal plane. Okay, number of nodal planes is equal to L. Number of nodes is equal to L. Number of nodes is equal to n minus L minus 1. Total nodes is equal to n minus L minus 1 minus L. LL cancel, that is equal to n minus 1. Nodes are also called radial nodes. Nodal planes are also called angular nodes. Okay. For d orbitals, shape of d orbitals. This is a dxy. dxy orbital. This is x-axis. This is y-axis. It has two nodal planes. ZX and YZ. Okay, this is a dxy orbital. It has a double dumbbell shape. Next, dyz orbital. This is a dyz orbital. This is y-axis. This is z-axis. This is a dyz orbital. It has two nodal planes, zx and xy. It has two nodal planes. And dzx orbital. Okay, in dxy, dyz and dzx, lobes are concentrated between the axis at the angle of 45 degrees. Okay, this is a dzx orbital. It has two nodal planes. YZ and XY. Okay, last two, dx square minus y square. This is dx square minus y square. Okay, it has two nodal planes. It has two nodal planes. Okay. In dx square minus y square, lobes are concentrated along the axis. Okay, last one dz square. This is a dz square. dz square orbital. Nodal planes 0. Nodal planes is equal to 0. A small circle present in xy plane. Okay, these are the shapes of orbitals. Okay, you understand?